Hello, hello. The next lesson, area of trapezoids, rhombuses, and kites. Again, the formulas will be given to you, but you have to know what to plug in where. First, the formula for a trapezoid. Now, just like the last lesson, you should look for your 90 degree in your picture. That's going to give you your height. And when I'm dealing with my trapezoid, wherever the 90 degrees is, I should write another 90 degrees right above it, because that's going to tell you which two bases you should be using. Because the height is going to connect your B1 and B2. Because this is the formula that you should be writing down in your notes right now that we will be using in class. First one, I'm looking for the height here. I have both bases. How am I going to look for the height of this picture? Well, when I see this height, or this 90 degrees, here's my second 90 degrees, so that's going to give me both bases. Now in this trapezoid, I could write in another height right here, and that would give me 90 degrees. And in this 90 degree picture, then, I can see that this is 45 degrees, so this is my special triangle S, S, S square root 2. Now if this whole thing is 14, and this little part is 8, I can subtract the 2 and get 14 minus 8 would give me 6. So this length right here would give me 6. And since that's equal to S, that means this is going to be equal to S. That means my height is equal to S. So then I plug it into my formula. 1/2 times 6 is my height, times my base 1 plus my base 2. And my answer here would be 66 millimeters squared. Remember, area, the units is always squared. So I'm looking at this second trapezoid. Again, you can always draw in a height. Height is always going to give you 90 degrees. So that's always going to be using SOHCAHTOA or a special right triangle. This special right triangle, this blue one right here, would be my 30, 60, 90. That means this would be my n square root 3, and 2n. So I could set 2n is equal to 4, because that's what was given at that side length. N is going to be equal to 2. That's going to help me find two things. It's going to help me figure out what this whole side length is, because since n is equal to 2, that means this whole thing would be 7 plus 2, because the top base is 7, so that's going to give me 9. And then it's also going to give me my height here. Again, since n is 2, my height would be 2 square root of 3. So now when I write it in my formula, it's going to be 1/2 times my height, which is 2 square root 3, times my top base plus my bottom base. My answer here would be 16 square root 3 meters squared, or if you put it in decimal format, it would be roughly about 27.7 meters squared. So in this problem, I will tell you if I want you to leave it as a square root, or if you should round to the nearest decimal. Now we're dealing with rhombuses and kites. So in this formula, as you can see, there's D's instead of B's there. D's are going to be your diagonal. When we're talking about any formula, whatever letter is used, it usually is the first letter of the word that is part of the picture. In this case, D1, D2 are the two diagonals that we have in our kite. So it's always going to be 1/2 times D1 times D2. Now if you're curious, why is it every time it's 1/2? Because these pictures are made up of small triangles. And if you remember, the area of a triangle is 1/2 times base times height. So that's where the 1/2 comes from. And first, my area of my kite. So I have to figure out whether my D1 and D2. D1 is going to be equal to this whole length. You have to make sure to have the whole length. So it's going to be 5 plus 3, which is equal to 8. D2 is going to be this whole length, which would be 3 plus 3, which would give me 6. So it would be 1/2 times 8 times 6, which is going to give me 24 centimeters squared. Remember, area is always squared. Now I'm looking for my area of my rhombus. Now, in both of these two diagonals, it only gives me 1/2 of the diagonal. But if you remember from chapter 6, if you don't remember this, you should write it down. The diagonals bisect each other. So this length will be the same as the length on the opposite side of it. And this length will be the same as the length of the opposite side of it. So my first diagonal, D1 in the purple, would be 25 plus 25, which would give me 50. My second length would be the green, D2, would be 22 times 2, which is 44. So I have 1/2 times 50 times 44, which will give me 1,100 feet squared. Right now you should pause the video. Yes, pause the video, and I want you to attempt this problem by yourself. Again, this is the next one that you should pause, and you should check your work. So unpause it, check your work, and pause it again. Your answer here should be 65.1 meters squared. So if you did not write down the formulas and the problems that we went over in this video, make sure you go back and write them down. Otherwise, you have a great day.